Hello, and welcome to Calculus, Lesson 126. Today, we are going to talk about partial fractions number 3. So this is our third installment on our partial fractions. So let's try and solve an integral that looks like this. So we have 6x squared minus 3x plus 1 all over an ugly factorization, I believe. It looks like it's 4x plus 1 over x squared plus 1 dx. So, how am I going to resolve this? Well, I'm going to split this into two partial fractions, a over 4x plus 1. But what's new this lesson is we've never had an x squared term in the bottom, okay? We can't factor this on the real numbers, so what I'm going to have to do on top is make this bx plus c. Why do I have to do that? Here I have only linear terms. Here I have a squared term, so I know that the derivative of that will most likely need to result in a linear term on top, right? The derivative of x squared would get you like 2x or something like that. So I must continue thusly. So what do we have now? Just making sure we did that correctly, which we did. So, I now have 6x squared minus 3x plus 1 equals a times x squared plus 1 and bx plus c times 4x plus 1. Gross? Well, yeah it is. And we are good to go. Yep. All right, so we use different A's, B's, and C's in the book, so that's gonna mess us up later, but that's fine. So we have x squared minus 3x plus 1 equals ax squared plus a plus bx times 4x plus bx, so bx times 4x, bx times 1 plus c times 4x plus c times 1. Now I'm going to collect all the linear terms or the constant terms. So it looks like 1 equals a plus c. Negative 3 will equal all the x terms. So it looks like I have b plus 4c. And I have 6 equals a plus 4b. From there, you can solve and then compute your integral. Is it painful? Well, yeah, it's going to be painful. I'm sorry. But, alas, we must continue. So, what will we have now? Once you solve that out, you'll find that that integral equals the following partial fraction. So we have 2 over 4x plus 1 dx plus x minus 1. So you'll get b equals 1, c equals negative 1, over x squared plus 1. Can we solve these integrals? Yes. Is it painful? Yes. Is that okay? Maybe. So on this guy, you can always split it like this. Remember your pretzel and get two terms out of that. So one of them will be an arctangent, one of them will be a simple ln. And that, my friends, is problem set 126. The key here, if you have an x squared in the bottom, you have to make it a linear term. So it should have a bx plus c on top. If it was x cubed for whatever reason, you would have bx squared plus cx plus d. So you have to include one lower power term in the top. And that is problem set 126.